When ancient man began to think about the universe around him, one of the first things to attract his attention was the mysterious wanderers of the night sky, which we call planets. For the planets seemed to move day by day, while the stars seemed to remain fixed. The planets move along regular, always repeated paths, and it seemed to the ancients that they were circling the Earth. When the first charts of the paths or orbits of the planets were made, some unexpected facts were discovered. For one thing, the planets did not travel uniformly, but changed their speeds as they changed their positions. Secondly, as positions of a planet were plotted over a period of time, it became apparent that they were not following a circular path, but were swinging forward and backward across the sky. From above, the motion might be represented by small circles about the edge of a larger one. The ancient astronomers were convinced that the planets moved around the Earth in orbits based on circular shapes. A particularly ingenious system was worked out in the 2nd century A.D. by Ptolemaeus, a famous astronomer of antiquity. According to it, each planet moves around a small circle, whose center in turn progresses along a larger circular guide path. This explained both the change in speed and the twisting loops. The Earth was still considered to be the center of the universe. This Ptolemaic picture of the universe was accepted for some 1,500 years until the time of the Polish astronomer Copernicus. In about 1530, Copernicus theorized that not the Earth, but the Sun is the center of the universe. The Earth is simply a planet and circles with the other planets around the Sun. He also found that the planets move around their own axes while circling the Sun like the Earth. Although Copernicus argued that the Sun is the true center of the universe, he still needed complicated geometric constructions to explain his theories, for he did not yet understand the true shape of the planetary orbits. Tycho Brahe, mathematician to the court of Emperor Rudolf at Prague, was born a few years after Copernicus died. He was the first to make really accurate measurements of the positions of the stars. The instruments which Brahe and his helpers used to chart the skies were simple ones. The telescope had not yet been invented, but the position of any star in the sky could be found by drawing two imaginary lines to the stars and measuring the angle between them. Simple as they were, Brahe's instruments enabled him to make these measurements with great precision. Brahe was an accurate and painstaking observer, but he preferred to make observations rather than interpret them. The secrets of the planets were waiting to be unlocked by someone who would work with Brahe's figures. Such a man was Johannes Kepler, a German. Kepler was sure that the universe had been arranged by God according to an orderly plan, and he was determined to discover it. He was struck by the idea that the shapes of the planetary orbits of the 6 planets known in his time might have some relationship to the 5 regular geometric figures. To his delight, after long calculations, he was able to fit these shapes into the planetary orbits: the octahedron, the icosahedron, the dodecahedron, the tetrahedron, and the cube. He wrongly believed that he had discovered the blueprint of the universe. Kepler published this theory in this first book, Mysterium Cosmographicum, The Mystery of the Cosmos. In 1600, at the scholarly court of Emperor Rudolf at Prague, Tycho Brahe read Kepler's book and wanted Kepler to join him as an assistant. Brahe's measurements at last were available to the man who could interpret them. Kepler's first assignment was to interpret Brahe's observations of the planet Mars. He discovered that the distance between Mars and the Sun was not always the same. Mars, therefore, definitely did not move in a circle around the Sun. Now, Kepler, willingly forgetting the earlier blueprint of the universe over which he had toiled, searched for a geometric figure which would fit Brahe's observations, and he found it, the ellipse. After centuries of confusion, Kepler had found the true path of the planets. Kepler's first law stated that every planet moves in an elliptical pathway around the Sun being at one focus of the ellipse. Kepler also found that planets move faster when they're closer to the Sun and slower when they are farther away. But a line drawn from the Sun to a planet will always sweep out the same area in a given amount of time, no matter where the planet is along its path. Each of these wedges was made during the same time interval, and each has the same area. This is Kepler's second law. Kepler worked out his third law many years later. This law relates the time required for a planet to move around its orbit to its mean distance from the Sun. If we take any two planets and call the times it takes to complete an orbit T1 and T2, the squares of these times, T1 squared and T2 squared, are mathematically related to the mean distances from the Sun, A1 and A2, in the following way. T1 squared is to T2 squared as A1 cubed is to A2 cubed. Kepler made other important contributions to astronomy. In a book on optics, he described his theory of the effect of the atmosphere on light rays passing through it. A ray of light coming from the stars to the Earth is refracted or bent as it passes through the Earth's atmosphere. That is why the observer on Earth does not see the stars in their real positions. When Galileo perfected the telescope, Kepler heard of it, mastered its theory, and suggested important improvements in telescopes and other optical instruments. After Brahe's death, Kepler stayed on at Emperor Rudolph's court to take his place. While there, he worked out new, more accurate astronomical tables, which still bear Rudolph's name. Such tables helped astronomers explain many of the movements of the stars, foretell eclipses of the Sun and Moon, and determine past and future positions of planets. During his last years, Kepler returned to Germany, where he continued to teach, research, and write. In November 1630, Kepler died, about 100 years after Copernicus first proclaimed that the Sun is the center of the universe. Before he died, Kepler wrote his own epitaph, which reads in part, "I measured the skies. Now I measure the shadows of the earth."